6-pounder cases usually arrive in truckloads by rail, and trucked in 200s soon come to their first processing. Firstly, the base is emerid and cleaned. The case is then passed on for the primer threads to be dusted out. This rough cleaning on the dirty side ensures that no bits of brass filings get onto the clean ways or into the filling shops. The base of each case is thoroughly emerid, as it will shortly be stenciled APT, armor-piercing tracer. Then the base of each case is punched with the letters CF, the operator using a steel punch and a brass hammer. CF denotes charge full. A further F will be added if the case is used again. Then half the side of each case is thoroughly emerid and stenciled with the lot number and the batch of the NCT propellant with which it is to be filled. Stenciling these necessary markings before the rounds are complete saves time and space in the assembly shops. The case is stenciled APT, armor-piercing tracer, with silver nitrate on the same bench. These letters are the first seen when the complete round comes out of its box and give a clear indication of the type of ammunition before the safety clip is removed. The case is now ready for its first and only CIA inspection on the dirty side. Points to be watched are the cleaned base and primer threads, the correct stencil markings indicating propellant, lot and batch number, the lip of the case, has it been damaged or bent in transit? No? Good. So every case is checked in strict rotation. Never is the sequence of examination altered. This ensures that nothing is forgotten or overlooked. The threads, the stenciled markings on the side of the case, the lip, undamaged, ready for the shot. Here's proof that such inspection is necessary, a damaged lip. Corrective measures will soon put it right, but for the moment rejected. But damaged cases are the exception rather than the rule, and 200 cases ready for filling pass on their way to the shops. Meanwhile, empty primers are unwrapped from greaseproof paper. Magazines are placed in one tray and bases containing plugs, cones and anvils onto the other. Primers are thus broken down and separated to insert the cap in the base of the primer and the powder in the magazine. A mechanical screwdriver is used for removing the plug and cone from the empty primer base, which is tightly held in position. The driver does the rest. Place the base under the driver to separate plug from the cone, and then drop them together into the box provided. Once more, under the driver, plug and cone separated and emptied into the box. The box is then emptied onto a sieve by the inspecting CIA. Very little shuffling of the sieve causes the small cones to fall through, leaving the larger plugs to be inspected first. As with all CIA inspections, the examination is thorough. Any plug showing the slightest blemish is immediately rejected, and that applies to the cones too. These small components play a large part in the measures taken to ensure the safety of our gunners. The CIA cannot be too critical in this most important inspection. There's still one more part to remove from the primer base, the anvil. Again, a mechanical screwdriver is used, and again, the operation is a simple one. Just hold the base under the driver, a few extra twirls to demonstrate how the anvil leaves the base, then into the box. In assembling the base of the primer, capping is the first operation. Working with a tray of inverted caps, the operator takes one cap at a time and places it in the primer base. Being heaviest at the bottom, the caps fall correctly into position and are ready for cementing. An operator holding the cap into position dabs RD cement between cap and base and passes it on to another operator, who, using a plunger to hold the cap in position, removes the surplus cement. The base, now cleaned, is ready for the cap to be pressed. The sides of the cap are then secured into position by a tool of the same size as the central stem of the primer, which will be inserted later. The press is hand-operated. There isn't a lot to learn, just place the base in position, swing the press, pull, and the cap is secured. Now the anvil is screwed into the base by the reverse procedure, the same result being obtained in a minimum of time and effort. Notice the method. Place the finger on the anvil and turn the base. The anvil is, as yet, only finger tight. The final tightening is a machine operation. Notice how this operator has speeded up production by ambidextrous use of her hands, and yet holding the base to the machine for exactly the same time in each case. Don't overdo that tightening, just enough to pass the gauging test that gauges the depth of the cap in the primer case. Correctly passed by a gauge with a 5 thou limit. And this, low, and therefore rejected. This exacting test is followed by the replacing of the cone, which stops a blowback. Their tapered shape allowing an intake of the flash from the cap but preventing an outlet. A dab of RD cement inside the plug, and then through a brass funnel is dropped the cone thin end downwards. Strict rotation avoids the possibility of missing one. Then with a hand press is stabbed the lot number, the work mark and markings showing where and when filled. Now follows the proofing. The top of the plug is cemented and covered with a white paper disc. Using a cement-covered stick, she inserts a dab into each plug and passes it to another operator, who with a luting stick picks up a white paper disc and sticks it to the cement. The CIA then tests to ascertain that the cones have been inserted below the plugs, a most important operation. Meanwhile, the magazine receives attention. A paper envelope is placed upon a stick, shellacked, and inserted into the empty magazine to receive a gunpowder filling. Using a bronze scoop and wooden hammer, operators fill the magazines with gunpowder. A scoopful of powder into the magazines, a few taps to settle it down, topped up, and the job is finished. All filled mags are placed in a tray, and the operators continue to scoop, tap, and top until a batch of 50 is completed. They are then handed over for shellacking. A dab on the threads of the magazine, and it's ready to be joined to the primer base. All fillings in both magazine and base being completed, they are now screwed together. In this operation, they are only screwed finger tight, care being taken that the threads engage correctly and not cross-threaded. So, with the exception of the final tightening in the primer key, a foot operation, the chuck holding the magazine in position, the primer filling and assembly is complete. The primers, boxed for transit, correctly docketed and lot numbered, reach the shops, where they are trayed base downwards in batches of 50 ready to be luting. Note, every lot is numbered. Never mix one lot with another. The luting is firstly rolled onto the table into long, thin lengths, and with these, the second operator lutings the threads of the primer. It's important that they are thinly rolled, for this enables the operator to follow and encircle exactly the threads. CIA inspection follows at the same bench. The CIA must ensure that 1, the lot number of the primer is correct, and 2, that it's properly marked and that the threads have been correctly luting. Next operation in sequence is the making of the pellet, which will be inserted later into the base of the shot. Operators work in fours, the work of the first being the filling of the mold with 20 grains of 261 compo. The method is simple and almost automatic. Take a mold and insert a copper funnel. With a copper scoop, spoon up a measure of 261 and pour through funnel into mold, tapping brass handle on copper scoop to free any stray particles. Remove funnel and press down powder and pass on. The second operator inserts a steel punch into the mold and presses down the 261 to make room for 10 grains of SR 399 compo above the 261. Once more, press the 261 with a punch, open the box, lift the lid, and take a scoopful. Scrape under the lid to give correct measure. Close the lid and insert the 399. The third operation is to compress the 261 and 399 into a pellet. The operation is watched and checked through a mirror. Now for the complete operation. The mold with 2 fillings is placed ready for number 3 operator, who inserts a steel punch into the mold and places it under the hydraulic press. 2 levers are applied during the operation, 1 for time, 1 for pressure. Correct. The steel punch is removed and inserted into the next mold, and the whole operation repeated. Points to notice: correct placing of mold under press, pressure and time and watch through the mirror provided for your own safety. The fourth operation is to remove the pellet from the mold. Place the steel punch into the mold and the mold under the extractor. Down goes the lever, out comes the pellet, which is then gauged and placed into a box. A point to notice is that after ejecting every third pellet, the mold must be cleaned out with the leather strip attached to the press. The next stage concerns the empty shot, which arrived on the site in boxes of 15. These boxes are trucked to the filling shops and emptied onto tables ready for work. The paper covers, which have kept the shot clean and guarded the driving bands during transit, are removed and replaced in boxes. These boxes and paper covers will be wanted again after the shot has been filled. The shot is stacked, ready for the first operation. Each shot is thoroughly cleaned with naphtha. Bits and pieces of the paper covering sometimes stick to the shot. These must be cleaned before leaving this bench for the first filling. Working from a covered box, the operator scrapes under a bar a full scoopful of tracer compo, the bar ensuring correct measure of 30 grains. Having poured this through the brass funnel top, she taps it down, and then, with the top still in position, the shot is passed on for its first pressing. The operator works behind a steel lighthouse guard when using this hand-operated hydraulic press. The operating key is under the bench. She places the shot into the mold and sends it up to meet the pressing tool. She takes shot from mold, top removed, shot passed on. The shot now receives its second increment. The operation differs very little from the first. Again, the measure is 30 grains, and again the compo is tapped and shaken down. Notice how the wooden block is worn through constant use. Again, the brass top is used, but this time the use of a copper funnel is needed too. Scooping up the increment, the operator ensures correct measure by scraping under the bar. She pours this through the copper funnel, taps, and passes on the shot. The second pressing is exactly the same as the first, but after pressing, all spare powder left unpressed must be emptied into a special box provided. Otherwise, if you know the first pressing operation, you certainly know the second. Don't forget, top off and the spare powder into the box. Here's a case of rank bad setting up, yet the brass top correctly guides the press. But be advised, depend more on your own carefulness and don't rely on the brass top to guide the tool. And remember too, keep your press clean. After every sixth pressing, the machine needs attention. The press tracer fillings are now topped up with 5 grains of SR261, and this filling is not pressed. Easy operation. Watch. A scoopful of SR261 into shot. Make certain it is in the shot, and pass on. A wooden stretcher is inserted in a cardboard tube to open it up just enough to take the pellet. The pellet and tube are placed in the shot and passed on. Quite an easy operation if you work to a system. Open the tube, insert the pellet. Remember, there's a right and a wrong way. Place pellet into the shot, pass on. The final pressing secures in the shot 1, the pellet just inserted, and 2, the 5 grains of 261. Note, limit of shot allowed to lie by machine at one time, 3. Procedure, top into shot, shot into press, pressure applied, shot from press ready for CIA inspection. Every shot is checked as it leaves the press for height of filling. If too high, rejected. If too low, rejected temporarily, but topping up will bring it up to the standard height. Fillings complete and inspected, base plugs are prepared, finally to seal the shot. Place half a dozen or so base plugs on a stick and cover with RD cement. Now drop them on the table, singly and inverted. That is, rounded side up. Pick up a shot and shellac the base. With the same brush, pick up a white paper disc, place over pellet, shellac thoroughly. The shot is now ready for base plug insertion. Place shot over plug, reversing normal procedure. It's cleaner this way. Once more, shellac the base over the fillings. Pick up white paper disc and shellac. Position the base plug and pass on for pressing. Operation takes place behind a lighthouse guard. Place shot in press, apply pressure, take out shot. Just glance at the base of the shot before it goes to the press. See how the plug stands proud of the shot. But one application of the press and the result can be clearly seen. The rim no longer stands proud but is flush with the base. Once more, shellac is applied to the now pressed base plug. With the same brush, the operator picks up a white paper disc and places it within the plug, and then proceeds to give it a coat of shellac. Here's the operation all over again. Shellac the plug. Pick up the disc and shellac that too. Then pass on to the CIA, who inspect each shot immediately it is processed. CIA must ensure that the paper disc has been stuck firmly, that no bubbles are below the disc, and that the whole thing is absolutely damp-proof. The nose of the shot is painted white. Instead of bringing the paint to the shot, the process is reversed. Each shot is dipped and slotted for drying. The entire operation, from dipping to an absolutely dry painted shot, takes only 10 minutes, an extremely fast time for a method that may appear old-fashioned. But old-fashioned or not, it's well able to cope with the rate of filling in each shop and to keep subsequent operators busy. This operator's job is to paint a red ring around the shot, which automatically makes a white ring below. Thus she fulfills the official description. The shot is painted black with a white tip, below which are 2 1/4-inch rings, one red and one white. The official description continues. Stamped on the body is the nature and mark and contractor's initials, and stenciled in paint is the design, number of method of filling, filled lot number, and when tracer is fitted, the symbol T. The CIA inspect that all these points are complied with. In addition, she sees that the paper disc has stuck firmly to base plug, that no bubbles are evident. All stenciled markings are inspected and checked before the shot is passed on for wrapping and packing. Now the shot again meets the paper covering that guarded the paint and driving band during empty transit. Once again, the same covers perform the same duties in the very same boxes. They leave the shop as they came, in rows of 5, 15 in a box. The next operation concerns the case, already cleaned and stenciled, and the primer, now correctly filled and lutinged in readiness for assembly. The primer is screwed into the threads of the case hand tight. All primers are kept in lot numbers. Never mix one lot with another. Remember, hand tight only. And pass on to the primer machine, which finally tightens the percussion primer in the brass case. There's nothing particularly difficult to learn here. Insert case with primer in machine and turn handle till threads are tight. Don't overdo the tightening, but the primer must be secure. Now the base is thoroughly cleaned. Using a copper rod, the operator cleans the keyholes to rid them of any surplus luting. When satisfied that all surplus is removed, she rubs off with a sponge cloth. The CIA now inspect the primer inserted into base, checking the tightening, cleaning, and depth of cap in primer. When satisfied, she fixes the safety clip. She uses a steel straight edge and feeler to check that the primer is exactly 15 thou below the base before fixing the protective safety clip. From the magazine, the NCT is trucked to the assembly shops in metal cases containing 110 pounds each. These cases are emptied into a wooden box which stands handy to the weighing scales. Contents of 2 metal cases only is the limit allowed in the box at one time. Everything is now ready to weigh the propellant charges. With an aluminium scoop, the operator fills a brass weighing case which has been adjusted to the scales so that the weight of the charge will be 2 pounds, 5 ounces, 6 grams exactly. Each lot of NCT has been proofed to find the exact weight to give the standard result, and operators at the scales must insert the correct weight to a single grain. To ensure that every piece of NCT thus weighed is poured into the case, a very large funnel is used and the NCT tipped in. Both the weighing and the filling takes place under the watchful eye of the CIA, who must check that the safety clip covers the primer. Watch how the funnel is moved from case to case after each pouring, and how the NCT is shaken into position before the funnel is removed. Immediately on top of the NCT propellant charge, now inserted, is placed a tin foil strip, folded into 4. It's essential that this tin foil strip be inserted into every case. At the same time, an operator is shellacking the sides of a leatherboard cup to be inserted on top of the charge and the tin foil. Be generous with the shellac, but don't be too long on the job, because when the cup is inserted, the shellac must be wet so that it'll stick firmly. Now the shellac cup is pushed down sideways into the case and gently rammed into the correct position with a wooden stick. A distance piece is then placed on top of the cup correctly to fill the space between the base of the shot and the cup holding the propellant charge. It's a good idea to see exactly what has occurred inside. The folded tinfoil strip on top of the propellant charge. The leatherboard cup, shellacked on the sides, pressed down with a wooden rod. Remember, both sides and center to make a tight fit, with the sides stuck by shellac to the case. Then follow the distance piece, resting on top of the leatherboard cup, filling up the space between that and the base of the shot, which will be joined to the case by being indented into the cannelure. The shot now painted and marked with a T for tracer, the lot number, the contractor's trademark and date, etc., are trayed in batches of 96 and trucked to the assembly shop to be joined to the case. But before the shot actually meets the case, yet another operation is needed. The cannelure of the shot must be RD cemented. Quite an easy operation. Remember, in particular, be systematic. Take a shot and thoroughly cement round the cannelure. Learn to turn the shot to the brush. It's quicker and easier that way. The RD cement must still be wet when the shot meets the case. Dry cement will not make a waterproof joint. Here's an operation that looks a confusion of movement, yet take the operation part by part, and you'll see this intricate business of joining case to shot is simple from the operator's point of view. The inserting end of the machine is reserved for the shot. The other end is for the case, locked in by a locking bar. Here's the complete operation. The wet cemented shot is positioned, propelled forward, and joined to case by indenting. The case being turned to the indenter at the other end. Out goes the locking bar, safety clip on, and complete cartridge is withdrawn. Again, at one end the shot, at the other end the case. Clip off. Be sure the case is correctly positioned. Locking bar down, turn case to the indenting machine. This is a job that makes good teamwork. The same team working together find themselves working to a system that is self-taught, a system that the team acquire themselves, a system the team will take a pride in and challenge all other ships to beat. The complete round with safety clip is now transferred to the operator, who cleans off any surplus cement that has oozed out from the join between shot and case. Using a sponge cloth, she thoroughly cleans around the joint till satisfied that all surplus is wiped away. Every round is cleaned before passing on to be checked by chamber gauge. This exacting gauge is a replica of the breech of the gun, and at the same time it checks the finished length of the round. All rounds must be exact in circumference and length. Check the base of the round with a steel straightedge for any proudness of base to the gauge. Partly remove from gauge and apply safety clip. Here's a round that will not pass the test and is placed aside for necessary rectification. But all rounds, even though they pass this test, have still to satisfy the final inspection of the CIA. The CIA check that the join between shot and case is a firm one. Any looseness would mean rejection, and the join free from RD cement. That the batch number and propellant letters are correct, and that the base is stenciled APT and with the case lot number. Then, when satisfied, she stamps her own work mark. She has made herself responsible. She makes the test a searching one. The join, the markings, and the base. If all is right, her work mark. While the descriptive and packer's labels are being prepared, the now finished round with safety clip is packed into a container. And from there into a tin packing box, C263. Round into container, container into C263. Now 2 dabs of shellac on inside of lid, and the descriptive and packer's label stuck down. The CIA label is placed under one of the clips of the packing box, and the filling factory's initials under the other clip. A hitch and tie off. Then well shellac both labels to make a seal. A green label with a red 6 is now pasted onto the front of the box, signifying to those who receive the rounds instructions for magazine storage. The tin packing boxes, each with 4 rounds, are stacked, ready for transit from the site. The shell filler's job is complete. Their work is done. But then the gunner's work commences. The gun crew is called to action. They're on target. The 6-pounder anti-tank gun is a quick-firing tank buster we've needed for a long time. So your rounds will play a very important part in winning the war. As the rounds enter the breech, you see the reason for all the care and accuracy demanded in the work of filling. One faulty round might cost the crew their lives. The tracer you filled enables the layer to control and improve the direction of fire. No tank yet built can survive within range of this gun, and you made the rounds that feed it. Keep going. You'll be proud of this 6-pounder ammunition one day.